This is Chapter 23, Module 1, Intro to the Respiratory System. The learning objective of this module is 1. Identify the organs of the upper and lower respiratory system and describe their functions. The respiratory system is a system of the body that is necessary to bring oxygen to the cells and to remove carbon dioxide from the body. It moves air in and out of the lungs, provides a surface area for gas to be exchanged with the blood, protects the respiratory surfaces from the outside environment, produces sounds, and participates in the sense of smell. The respiratory system can be divided anatomically into the upper respiratory system and the lower respiratory system. The upper respiratory system is above the larynx. The lower respiratory system includes the structures below the larynx. The respiratory system can also be divided functionally as a respiratory tract that consists of a conducting portion and a respiratory portion. The conducting portion brings air into the lungs and includes structures from the nasal cavity to the terminal bronchioles. The respiratory portion includes the surfaces where gas is exchanged with the blood, including the respiratory bronchioles and the alveoli. The alveoli are air-filled pockets within the lungs where the gas exchange takes place. The conducting portion of the respiratory tract is covered by a respiratory epithelium. The respiratory epithelium is a pseudostratified, ciliated columnar epithelium in the nasal cavity, pharynx, and the superior portion of the lower respiratory system. The cilia provide vacillating motions that help propel debris and pathogens up and out of the respiratory tract. In the upper respiratory system, trachea, and bronchi, the respiratory epithelium contains mucus glands that secrete onto the epithelial surfaces, helping to trap dust and debris. The respiratory epithelium in the alveoli is a very delicate, simple squamous epithelium. It is very thin, less than 1 micrometer. It allows for the exchange of oxygen and carbon dioxide across the surfaces. The respiratory passageways is one way that the pathogens can enter the body. So the respiratory system must present a good defense system against invading microorganisms. The mucus cells and glands produce a mucus that bathes the exposed surfaces and washes away foreign cells and particles. The cilia sweep debris trapped in the mucus toward the pharynx in a motion called the mucus escalator. The nasal cavities help to filter the nasal cavity to remove large particles, and macrophages around the alveoli engulf small particles that reach the lungs. Air first enters the respiratory system through the nostrils or external nares of the nose and enters into the nasal vestibule. Hairs within the nasal vestibule are the first area of filtration that filters out particles like dust and foreign cells that have entered. Mucus secretions and tears help to clean and moisten the nasal cavity. Mucous membranes must also be kept moist to avoid drying out. Air flows from the vestibules and into the nasal cavity. Air will pass the superior, middle, and inferior meatuses that are protrusions on the wall of the nasal cavity that create constricted passageways. These constricted passageways help to produce air turbulence that warms and humidifies incoming air and traps particles with mucus secretions. The oral cavity is another entrance into the respiratory tract. With the oral cavity are the hard palate that forms the floor of the nasal cavity and separates the nasal cavity from the oral cavity. The hard palate is part of the maxillary bone as well as the palatine bone. Posterior to the hard palate is the soft palate. The soft palate divides the superior nasopharynx from the lower pharynx. The nasopharynx is the portion of the throat just posterior to the nasal cavity. Air flows into the nasopharynx from the nasal cavity through the internal nares. Again, the mucosa of the nasal cavity warms and humidifies the inhaled air to prepare it for the arrival at the lower respiratory organs. Breathing through the mouth bypasses this important step. The pharynx is a chamber that is shared by both the digestive and respiratory systems. It extends from the internal nares to the entrances of the larynx and esophagus. It can be divided into the nasopharynx, the oropharynx, and the laryngopharynx. The nasopharynx is the superior portion of the pharynx and contains the pharyngeal tonsils as well as the openings to the left and right auditory tubes. The oropharynx is the middle portion of the pharynx that communicates with the oral cavity, and the laryngopharynx is the inferior portion of the pharynx that extends from the hyoid bone to the entrance of the larynx and the esophagus. As air enters the larynx from the pharynx, it will come to a narrow opening called the glottis, a narrow opening surrounded by cartilage structures. The 3 cartilages of the larynx include the thyroid cartilage, the cricoid cartilage, and the epiglottis. The thyroid cartilage is a hyaline cartilage that forms the anterior and lateral walls of the larynx. Its anterior surface is called the Adam's apple or laryngeal prominence. Ligaments attach the thyroid cartilage to the hyoid bone, the epiglottis, and the laryngeal cartilages. The cricoid cartilage is a hyaline cartilage that forms the posterior portion of the larynx. Ligaments attach the cricoid cartilage to the first tracheal cartilage. The epiglottis is composed of elastic cartilage and contains ligaments that attach to the thyroid cartilage and the hyoid bone. The thyroid and cricoid cartilages support and protect the glottis, which is the opening into the trachea or windpipe. During swallowing, the larynx is elevated and the epiglottis folds back over the glottis, preventing entry of food and liquids into the respiratory tree. The larynx contains 3 pairs of smaller hyaline cartilages that function to open and close the glottis as well as to produce sound. Sound is produced as air passes through the glottis and vibrates the vestibular ligaments that contain delicate vocal folds. The vocal folds vibrate to produce sound. Sound is varied by the tension on the vocal folds. The vocal folds involved with sound are called vocal cords. Phonation is the sound produced at the larynx, whereas articulation is the modification of sound by other structures. During puberty, the vocal folds thicken, causing the male voice to deepen. The submucosa beneath the mucosa of the trachea contains mucus glands. Tracheal cartilages protect the mucosa of the trachea. The 15 to 20 individual tracheal cartilages strengthen and protect the airway from collapsing. These tracheal cartilages end where the trachea contacts the esophagus. The trachea divides into the right and left primary bronchi. At the point of separation is an internal ridge called the carina. The right primary bronchus is larger in diameter than the left and will descend at a steeper angle. The primary bronchi enter the lungs at the hilum of the lungs, that is a specific area on the lungs where pulmonary nerves, blood vessels, and lymphatics all enter the lungs. The right and left lungs are in the right and left pleural cavities. Each lung has a base, which is an inferior portion of each lung that rests on the superior surface of the diaphragm. Each lung has separate sections called lobes that are separated by deep fissures. The right lung has 3 lobes, superior, middle, and inferior, that are separated by the horizontal and oblique fissures. The left lung has 2 lobes, the superior and inferior lobes that are separated by the oblique fissure. The left lung also has an indentation called the cardiac notch to provide space for the heart. The right lung is wider and is displaced upward by the liver. The anterior and lateral surfaces curve to follow the inner contours of the rib cage. The left lung is longer and is displaced leftward by the heart, forming the cardiac notch. The cardiac notch accommodates the pericardial cavity that sits to the left of midline. On the medial surface of the lung is the hilum, which is irregular in shape. The great vessels of the heart and the primary bronchi enter the lungs at the hilum. The pulmonary artery typically sits superior to the pulmonary veins. The bronchial tree is formed by the primary bronchi and their branches. The primary bronchus branches to form the secondary bronchi. 1 secondary bronchi goes into each lobe. The secondary bronchi branch to form tertiary bronchi, or bronchopulmonary segments. There are 10 bronchopulmonary segments in the right lung and 8 to 9 in the left. The walls of the primary, secondary, and tertiary bronchi contain progressively less cartilage and more smooth muscle. The increased smooth muscle is accompanied by muscle tension that affects the airway constriction and resistance. Each tertiary bronchus branches into multiple bronchioles. First, they branch into terminal bronchioles. 1 tertiary bronchus forms about 6,500 terminal bronchioles. The bronchioles have no cartilage and are dominated by smooth muscle. Autonomic control regulates the smooth muscles, controlling the diameter of the bronchioles and the airflow and resistance into the lungs. Bronchodilation is the term given to the dilation of the bronchial airways. It is caused by sympathetic autonomic nervous system activation, and it reduces resistance. Bronchoconstriction is a term given to the constriction of the bronchi, and it is caused by the parasympathetic autonomic nervous system activation in response to histamine release from allergic reactions. The lobes of the lungs are partitioned into smaller portions called the pulmonary lobules, separated by partitions called septa. Each terminal bronchiole delivers air to a single pulmonary lobule. Each terminal bronchiole branches to form several respiratory bronchioles where gas exchange takes place. Each pulmonary lobule is supplied by pulmonary arteries and veins. The respiratory bronchioles are connected to alveoli by alveolar ducts. The alveolar ducts end at alveolar sacs that are common chambers connected to many individual alveoli. Each alveolus has an extensive network of capillaries that are surrounded by elastic fibers. The alveoli contain an epithelium that consists of simple squamous epithelium and are patrolled by alveolar macrophages that seek out dust particles. Other cells of the alveoli produce a substance called surfactant that is an oily secretion containing phospholipids and proteins. Surfactant coats alveolar surfaces and reduces surface tension. Respiratory distress syndrome is due to the collapse of the alveoli that is caused when pneumocytes type 2 cells do not produce enough surfactant. Gas exchange occurs at the thin membrane of the alveoli called the respiratory membrane. Gases such as oxygen and carbon dioxide must diffuse across the alveolar membrane, the capillary membrane, and the basement membranes, holding them together. These three components, the alveolar, capillary, and basement membranes, make up the respiratory membrane. Oxygen will diffuse from the alveoli, across the alveolar epithelial cells, across the basement membrane, and across the capillary endothelial cells to enter the bloodstream, where it can then be transported to the tissues. Carbon dioxide must diffuse across the capillary endothelial cells, across the basement membrane, and across the alveolar epithelial cells to enter the alveoli, where it can then be breathed out of the lungs. Diffusion across the respiratory membrane is very rapid because the distance is short and the gases, both oxygen and carbon dioxide, are lipid soluble. The respiratory membranes receive blood from the capillaries of the pulmonary circuit. The capillaries form a network that surrounds each alveolus, helping to form the respiratory membrane. Oxygen diffuses from the alveoli into the capillaries, and carbon dioxide diffuses from the capillaries into the alveoli. The capillaries, now laden rich with oxygen, merge together to form the pulmonary venules, then the pulmonary veins, to return to the left atrium. The right and left lungs are separated by a space in the thoracic cavity called the mediastinum. Each lung is held in the pleural cavity that is lined with a serous membrane called the pleura. The pleura consists of an inner visceral pleura that covers the lungs and an outer parietal pleura that lines the pleural cavity. Pleural fluid lubricates the space between the two layers, helping to reduce friction during expansion of the lungs during inspiration. This ends Chapter 23, Module 1, Intro to the Respiratory System.